All right. So we didn't have lab this weekend. I was at CornCon this coming weekend. I have a wedding to attend to where I need to be actively involved. However, I do have a number of good things. I'm going to post a talk from a professor who used to be basically a director and of cybersecurity at St. Louis University. So I'm going to post that talk, and then we're going to have a live chat next week, this time during class, with an individual about obtaining employment in cybersecurity, getting within the commercial sector or the federal government sector. He will talk. So I will pass out a different Zoom link for that because there will be other people that will be invited, and so I'll provide that information. And then that weekend, we will have a talk as well, and then we'll have a panel. So these things will be forthcoming. And then later today, you will see the first published C2 Safe magazine. And there'll be some information for you to see and stuff like that. So I'll have that posted. And then an update about Kosovo. I've been in contact with the U.S. Embassy in Kosovo. So they are identifying organizations. And so by this Friday, I should have those organizations. And then we will be able to work on placing students and stuff like that. All right. So this particular domain is software security. What do you guys know about software security? Okay, Christian, I
Uh,
saw your mic come off. You're about to say something.
no, it just unmuted while I was joining.
Oh, okay. All right, go ahead, Michael.
Software security, I'm guessing it's basically securing software against like malicious attacks. For example, assuming you had a software that involves logging in or like transactions, then you'd want to make sure it's secure against people who would try and intercept them or take advantage of weaknesses.
Exactly what it is, right? So when cybersecurity, so before cybersecurity, it was like information security, digital system security, then it was information assurance, then it was IT security, then it was automated information system security, right? So it's always been a different name, right? Associated with cyber and stuff like that. They just use cyber to encompass everything. Now, here's the interesting part. When people thought about cybersecurity, they were only focused on the system, right? They were just focused on protecting the network. Now, when you're only focused on protecting the network, where do you think most of your vulnerabilities are going to end up?
Physical.
A cat, not physical. It's going to be software, right? If I'm focused about firewalls and intrusion detection systems, but I don't care about the supply chain that deals with the software configuration, I don't really care about
Human
the integrity
aspects
of
as
the
well.
applications. Sorry, Cat.
Like human aspects, maybe maybe someone having too much permissions
Yeah,
in the
anything and
software.
everything. So Cat, it will be anything and everything tied to software. So, how many people here are actually CS majors? Who's a CS major? Okay, Naeem. So, Naeem, and CS, not your cyber class, and CS and your software architecture, software development, programming theory, do you talk about cybersecurity at all or secure design?
Yes, but like we have in bits and pieces. I'm CS for my undergrad and ITM cyber for my master's. We have like kind of in bits and pieces, more so from the aspect of making sure that like with object-oriented programming, for example, ensuring that only certain users that are meant to be part of our system can execute certain aspects of the code that they're supposed to, and things of that nature.
Okay. So it sounds very limited.
To some degree, and then maybe like with SQL, the injection, SQL injection attacks, things of that nature. Outside of that, I don't think too much though. Not an insane amount.
All right, Kat, what about you? Former CS major.
Yeah, I I didn't really notice any specific discussions of cybersecurity in any of the courses I took. But I also only took about like four CS courses because I got a lot of transfer credits. So
Okay. Your transfer credits, were they CS or IT?
Yeah, I had a lot of like programming transfer credits from community college and one APCS credit, and they didn't discuss cybersecurity really in any of those either.
Okay. Now, I bring that up because my first doctorate, right, is in computer science. If you guys didn't know, right? I got a couple of these things. I collect them like infinity rings, infinity stones. Um, so my first one was CS, and there were no cybersecurity courses in my doctorate program. Right, a lot of stuff on. I did requirements engineering, I did system engineering, software engineering. I focused a lot on software architecture. Even had classes that dealt with innovation, featuring innovation, usability, interaction, but nothing on cybersecurity. So that is the interesting part, right? Nothing focused on cybersecurity. And here I am, supposed to be a doctoral student learning ins and out about programming and software design and software architecture, but nothing about security. So that means that there were generations of CS majors graduating, going out to the open job market, focused only on it's called the capability maturity model, right? So the capability maturity model index deals with quality, software quality. That was the big thing. Is it repeatable? But nothing in terms of is it secure, right? Is it repeatable? That's all that they were focused on. Quality and is what you've done, is it repeatable? And so that created a huge issue. So now it's like, okay, well, what is dead code? People think, oh, well, you just throw in the code, just comment it out, not realizing that that same code you comment out can be used. Or you have a backdoor that's placed in there, and it's like, okay, well, you have a backdoor. Yeah, you should remove that backdoor. That should not go into production. So all these particular faults became issues. And software doesn't just meaning, well, it also means like database application, SQL was mentioned, SQL, MySQL, Postgre, all this stuff, all these, anything that you're dealing with, even if you're doing like scripting, we'll just say like shell scripting, stuff like that, even that can be tied to software development. It's not hardcore programming, but it is, you're still programming something. So that is one of the issues. So back in 2008, ISC Squared, the International Information Security Certification Consortium, it's a mouthful, they developed the Certified Secure Software Lifecycle Professional, the CSSLP. I'm actually one of the first certification holders. I spent many years writing the actual exam for the CSSLP. And so I can tell you more about it in class. We could talk about it and stuff like that. I don't know if I have a copy of the book. I'm looking back now at my library, and I don't have a copy. If I had to order a copy, or maybe I could share a freely distributed copy so you can see. But those items were not covered, right? Everything was just focused on the outside, the how does traffic move and stuff like that, but nothing in terms of the actual applications. What's interesting when you think about like supply chains or like software, like even Adobe doesn't develop the entire suite itself. There are lots of people that are developing various components to the Adobe software, right? Lots of different suppliers, or you can say subcontractors. And to make sure that all of those particular applications are secure, that they're incorporating, they're integrating to their system, and then that there's something done called a source code analysis. Right? A source code analysis. They're dynamic, they're static. We'll go over that. The actual application, the task we'll be doing will be a static source code analysis. All right. So this slide, it's a bit dated, but the key is to understand that a number of organizations, federal organizations, we're trying to increase your certification accreditation rate, right? So certification is a process that you go through to say, hey, we want to be able to use these systems and tie them on a DoD network, Department of Defense network, right? So you go through the certification process, and once you're done, you get a credit. You get what's called an approval to operate. You can operate for 3 years. Interim approval, which means 6 months to fix or remediate any particular issues. Then you get your full approval to operate. And so a lot of agencies were not in compliance, right? And so you see here, it says, yet 20 out of 24 major agencies indicated that inadequate information security controls were either significant deficiency or a material weakness. During this period, there's something called DITSCAP and DICAP. DITSCAP, Department of Defense Information Technology Security Certification Accreditation Process. And then you had DICAP, which is the Department of Defense Information Assurance Certification Accreditation Process. And now you have, RMF, and now you have another particular model for cybersecurity. But those were the predecessors. There's actually a predecessor to those two that I just mentioned as well. And so organizations to turn on their systems, they're supposed to turn on something on a government network, had to be accredited. And so they were saying here that basically that a number of these systems had major issues. And that's what this is showing, right? Major issues. So 20 out of 24 agencies, that's almost all agencies, had issues. This could be Department of Treasury. This could be Housing and Urban Development. Before the previous administration, the White House put out a report. It was the FISMA report. And the FISMA report would provide the rankings of the agencies. It was like a score sheet, right? It would say this particular institution has an A, a B. DOD was black, so it was never listed. But it was interesting to see which agencies actually failed and how poorly they were ranked. It's scary when you think about it. All right, so here it just says that incidents keep increasing. So when you look at this slide, it just shows that unauthorized access kept rising, right? So unauthorized access just kept rising. So here it just says the number of security incidents, they keep growing. Now, with what you've seen in either the lab or in class, how difficult is it to do a attack?
Not that hard, depending on what attack you want. Just using the denial of service, though it's not used as much, it's pretty easy, especially you just need to continually try and load a site, basically.
Okay. Someone else.
I would say, it certainly probably isn't, agreeing with Michael, it really isn't that hard depending on what you're trying to do. If there's just some vulnerability that, people just didn't account for at all, that, is fairly easy to exploit. It's just a matter of finding the right tool that can help you accomplish that mission. And maybe even, maybe you can even be a script kiddie and still pull something catastrophic off.
Oh, Naeem, you're talking like you're a professional hacker. You said the mission.
Wait, I'm sorry, what?
You sound like you're a professional hacker in your spare time. You said, "Oh, the mission." I'm like, "Oh, wow, the mission." Okay, I'm not gonna call you out, but you sound very versed in and passionate in what you're talking about there.
Well, no, I just say that's probably coming from Miss Professor Trickstad class.
All right, so there's different types of software. There's COTS, there's GOTS. COTS is commercial off the shelf, right? So here just saying that it's just showing that there's lots of issues, flaws in software that you buy off the shelf, right? And it just shows that the trend is upward. Remember, when you buy stuff from stores, a lot of these particular organizations that are developing applications, they don't have to be compliant with CMMI, right? So they will put out stuff and there will be numerous flaws in these particular applications. All right. I'm pretty sure people here have jailbroken their phone, and that may be through an application they've loaded that has allowed them to do other things like, put in apps that they shouldn't have available and stuff like that. So this is interesting. So this is older slide, and I'll show the newer ones. But in terms of the top 25 dangerous programming errors, for 2 decades, it's been the same. They've changed the name of the programming errors, but they're pretty much the same verbatim, which is interesting. So if you are trying to protect an organization, these are the ones that you should focus on. And if you're trying to, things are rough, Sally Mae, or I think it's Mohilo, who's the new loan provider, they're coming after you, and you're like, you know what, I'm going to be a bad guy. These are the errors that you should focus on. right? SQL injection. It's easy, right? You type in the website, you put the PHP question mark, ID equals whatever, and then boom, pages will
There's
come
a
up.
joke that exists about it.
What's the joke?
It's like it's like a comic strip. A lot of people probably seen it, but it's like but it's basically a parent is getting called from from the school about something that like that the fact that his the child's name was Bobby, and then it's a drop table semicolon, which which according to him like destroyed the entire school's database, and like the mother's basically you should have cleansed you should have cleansed the inputs.
If you have a copy, send it to me. I like to put it in the next newsletter. Please send if you find a copy. Now, with all these, you can just look through some of these and say, okay, well, how is this an issue? Like, why are people doing stuff like that? Like, one says using hard-coded cryptographic hard-coded passwords, right? Hard-coded passwords. It's like, well, who would use that? Incorrect calculation of buffer size. Use a one-way hash without a salt. Missing authorization. Missing authentication for critical function. You just look at stuff like this makes no sense. Like, who makes these issues, makes these errors? Many people do, believe it or not, many people do. All right, this is like, again, they've done one for, I think it was like 2020, very recent, but it's the same errors, right? That's what I meant. Like, the problems are the same. This website is called Open Web Application Security Project, OWASP. I was actually a member. I was a founding, I founded the Huntsville, Alabama chapter years ago. And then we would do a lot of stuff on source code analysis and stuff like that. A lot of CS, MIS majors. We'd get together and we'd, host our weekly events, mainly at the barbecue joint. And it's like a Mexican restaurant. But yeah, that's pretty much where we held our stuff. Got our laptops together, went through a bunch of different things, tried new tools, ran these tools to see how these things worked. So you can see a lot of the stuff's the same. Injection is at the top. One of the easiest things to do once you're able to do an injection, you could, of course, run a myriad of other tools to see what else is flawed. All right. All this means is his size matters. The more complex something, the more, I guess, touch points a system has, the more complex it gets. That's all it means. Here it just says, as the project size increases, errors usually come more from the requirements of design. So when you have something to fix, you need to fix it from the requirements. As you get into design and construction, if you have to go back and fix, it's going to cost you more money. Here, this is policy, standards, procedure, baseline guidance. And so if you look on the right, law, regulations, they become an executive order from the president, DoD directives or joint doctrines. They flow down to DoD instructions, policies, and memorandums of understanding. And from there, it flows to standards, processes, baselines. When it says max security controls, that is mission assurance controls. This dealt with DITSCAP and DICAP. This is no longer done, but there were actually security controls that would be like, all right, you have a MAC 1 system and maybe is top secret, right? And it will spit out controls that you need to be compliant with. Those controls were replaced by the RMF, and that is what occurred. But I have a paper that was published using those controls, and I'll share that with you guys. I just sent out an email with the paper attached, and you can see exactly how those controls look and how were things done on these federal systems. Now, in the actual paper, I didn't use a federal system. I did use the actual template and put dummy data in there and talked about it. This is the Clinger-Cohen Act of 1996, basically defined the federal agencies and the DoD's acquisition, management, and use of IT. And then it defined roles and responsibilities of the agencies and their executives. They used to have there's something called a DAA. So you had designated approving authority, DAA. You had IAM, information assurance manager, information assurance security officer, and so all of these particular roles were responsible within the C&A process, right? That's what that is. All right. You have the Federal Enterprise Architecture Network. Remember, you have DODAF, you have TOGAF. You have all these enterprise architecture frameworks who help you develop your systems at a high level all the way to a low level where there's different views for individuals who work in a system, whether they're the program manager, the actual user, developer, and stuff like that. COBIT, this is the control objectives of business information technology. There's actually certifications that deal with COBIT. I guess you could say this is GRC as well, the first of GRC. ISACA was the organization that put something out. There's actually a certification called the Certification of Governance of Enterprise Information Technology. It's a pretty good cert. I actually have the cert myself. I think I've had it for over 10 years. Yeah, over 10 years I had the cert. But it deals with ITIL. ITIL, another cert you can get. You have ISO 27000. You have PMBOK, which deals with project management body knowledge, which is get another cert. But COBIT, the key thing about COBIT, it has 5 focus areas: strategic alignment, value delivery, resource management, risk management, and then performance management. And these are particular areas that deal with enterprise information governance. So here it talks about augmenting IT governance with security. So basically just adding in a governance component with security. That's all it is. Like when people talk about adding security into development lifecycle, you're basically injecting cybersecurity. Same thing with governance. So GRC, governance risk compliance. This is like the first certification that really dealt with this. All right, this is the lifecycle process here. This is the ISO 12207 software lifecycle process. The key one, what I want to show is this. So this is what the Department of Defense uses. Oof, this is a monstrosity. This is the acquisition technology and logistics lifecycle. Sorry, acquisition technology and logistics lifecycle. So this is used to manage projects. This Thursday, when I come to class, I will go through this. This right here, this defines what I did for years. Yeah, so Naeem, so this one's interesting, right? So I was a senior program manager and I was responsible for all of this. So I went through a lot of training, usually had to have a master's, MBA, or some master's in management. I had a grad certificate in project management. And then I went through the Defense Acquisition University's courses in system engineering. You get certified in program management or acquisition management. But yeah, people go through this entire process. So this process defines how a government program gets funded by Congress, by the Hill, and how that funding goes to joint capabilities, how it goes down to actually developing requirements. So you go from preliminary design review, critical design review, then you do low rate initial production, LRIP, full rate production, and then you decide if you're going to either maintain a system or decommission it. But if you do this job, you can make quite a bit of money. Now, is it stressful? Yes. Is it stressful? It is extremely stressful. You will do this job and nothing else. So this is one of the few jobs I say in life that they expect 100% of you. So if you do great on the job, they're like, all right, you don't get a pat on your back or attaboy. That's your job. It's what you're paid to do. But yeah, it's quite a bit. So generally the people that do this, they have a background, either they're a specialist. For myself, I was a system engineer. So I did cybersecurity from the system standpoint. So I did software, network. What else did I do? I did like Tempest. I did things with like hardware. So it's like not just Tempest, like cryptographic keying and stuff like that. I did physical security. So all of that allowed me to go into other aspects of the system, right? So then I had to, sit in meetings with mechanical engineers, software engineers that weren't focused on security, and you have a different viewpoint because you're just focused on the entire system, like all those abilities, reliability, maintainability, usability. It's a lot. So you have to be able to understand a little bit about everything to make some key decisions. And then, of course, you're responsible for the budget for everything. So it's quite a bit. The last program that I did as a program manager, it was a $250 million portfolio over 5 years with the transportable Black Hawk operational simulator. Before that, It was Silent Night Raider with U.S. Special Operations Command. It was selling hardware as a product line manager. And then I had, I guess you could say, research development funding. But each one of those things sat somewhere in his life cycle. It was a lot. But I went through weeks of training and grad school and some other stuff. So that you can do it, but you got to think about, is it what you really want to do? Because one of the problems when you're doing this as a program manager, you own the life cycle, you own the budget, but you don't own the people. You don't own the people. The engineering managers own the people. You're the program manager. So you're responsible for this. You're the one that communicates, to the customer. I would have weekly meetings with the customer. And if it's multiple programs, then it's different programs I would meet with the customer on. All right, so this right here, if I don't think anybody here has taken any industrial engineering classes, but when you think about the gate process, right? The gate process means to get through gate 1, you need to meet these you have these prerequisites to get to gate 1, and then once you pass the items for gate 1, then you can go to gate 2, but you need to have these prerequisites that actually sit in gate 2. That is all this is showing, right? This is just showing that each life cycle has its own milestone and review. That's all you see here, right? So you look here, when I was talking earlier, okay, system concept review, system requirement review, SR, then you have PDR, and you have these other items, and then you can see like how these items meet with these other life cycle, right? So system certification, test readiness review, right? Security test and evaluation, this is where you're going to get your testing for your approval to operate, interim approval to operate. That's what you have right here. And then system security authorization, that is your, you get authorization to operate. And then continuous monitoring just means that you're monitoring, different particular security events and stuff like that. Once you know one life cycle, the rest will come to you. Seriously, like, do not think that, you have to understand everything verbatim. You understand one, you can say, all right, well, I know I need to be compliant with this particular life cycle. When is my approval? When can I field it? Well, when can I go for testing? Well, you can go for testing when you actually done internal testing. So if you're a system or software engineer or whatever, think about when you're going to actually test it internally, test against controls, see how the test works. After that, then you can have a third party come and test it. You're like, okay, now I know how to lay this particular life cycle out. That is sort of the way that I've kind of done it. And I've worked on numerous jobs where I've either been a system engineer, I've been a software engineer, I've been a specialty engineer. And it's because I take a different viewpoint when I look at these life cycles. I do not get engrossed in like, okay, ISO, whatever says this, it says that. Life cycles, a lot of them, they're following a basic life cycle, and they all have their tweaks to meet that particular industry or reg, right, or regulation. It's not that difficult. All right, so all this says right here just says that by development stage, 85% of the code has already been committed. And then, so if you look here, you look at the cost, of the costs have been committed. So if you look here, right? So if you look at the lifecycle costs, the further along you get in a project, the more costs have been committed. That's all it's showing, right? So if you fix something, the concept or design is going to be cheaper. The longer you wait, the more expensive it's going to get. That's all it's showing. All right, CMMI. So this is a capability maturity model index. This is maintained by the Software Engineering Institute at Carnegie Mellon. And so CMMI is a way of producing repeated results or expected results. It looks at performance, process, and then maturity. All right, so there's 5 levels: initial, repeatable, define, manage, optimizing. Level 3, so there's different capability maturity models, but they're pretty much all the same as well. Remember, one process is like the other. There's a model that there's a project management function of this as well. You look at level 2, it's repeatable, means there's someone managing, right? There's some project management. Level 1, I call hero. Hero is like you have one particular star, and that individual can do anything, and I mean anything, but they can't repeat anything, right? It's like, okay, that person's gone, and we need you to develop the same product. You can't because your hero's gone, so you're pretty much, out of luck. 4 means is managed, and so everything's detailed. You have processes that you follow, that you're tracking and stuff like that. So things are quantitatively controlled. Level 5 means that, say it takes me 100 hours to build something for you, right? I can put together a piece of your house for 100 hours. The next time you come to me, you can well, Mo, what can you do? Like, I can do it in 80 hours. Like, wow, you can shed time. I can shed time, and it's going to save you money. Plus, it's going to be better than you got last time. And so now I've optimized. Like, I've come up with a way to get the job done sooner, to save money, and to get the same quality, if not better. So for CM, capability training model, CMI as well, there was a process that dealt with Lean Six Sigma. Has anybody here heard of Lean Six Sigma? Okay, no one has it. So Lean Six Sigma, it was a process that people get certified for doing this particular type of work, like managing waste, right? So you would have Six Sigma, yellow belt, green belt, and black belt. And so a number of organizations will require people, certain engineers or program managers, to be Six Sigma certified. So at 2 different organizations, I had to go through Six Sigma certification. I did it at Rockwell Collins, and then I did it later at Textron Systems, where I had to get certified in Six Sigma to show that, I actually had a project. So I had to work this project, show that I could save the company money. This is the project I used. I had someone come evaluate it, and I was given my certification. It's a good certification. But again, mine's I didn't keep up. I got to just get them, and I kind of like let them dangle for a bit. But Six Sigma, it's a good one. All right, here is the software. Seriously, this is system security engineering capability training model. It's the same as the others, right? Not perform informally. Now you track, so now you have some level of project management. Level 5 all the way to end, you're continuously improving. It's the same exact thing. Again, do not dwell on the name or name of it, right? They're pretty much the same. All right. So I'm going to stop here, and we are going to finish the rest in class. And what I'm going to do now is we are going to do some of the actual hands-on application. So I'm going to share my screen. Go to display. Okay, perfect. All right, I'm going to, let's see. All right, you're going to go to this website here, this is sourceforge.net. I'm going to share the link. Let me share the link with you. And you're going to go to this site, right? Just have it ready. I'm going to give you another link as well. The other link I gave you is for this site. This site here, this is OWASP. Remember I was talking about OWASP, right? So Open Web Application Security Project. These are various tools that you can use to do source code analysis, right? So dynamic means that you're running the actual analysis while the code is running. And static means that it's not being used, right? It's, because you say still. So these are tools. It shows, if it's open source or commercial. what you can run it against. And we're going to go over one called Flaw Finder. There's Flaw Finder, open source, and it runs C, C++. Go here to Flaw Finder, and it shows the CWEs. Right? So CWE is common weaknesses and exploit, common vulnerabilities in narration. So let's just type in MITRE CWE, common weaknesses in narration. Oh, you see right here, 2023 top common, most dangerous software weaknesses. You click here, you can see the list. And we can see the list. And this is for this year. And there we go, SQL injection. Not number one, but it's up here. It's still up here. Again, the same things. All right. So going back here, what you're going to do is you are going to you're going to install Flaw Finder first. So let's install that. So sudo apt install Flaw Finder. So Flaw Finder is installing. Once you have Flaw Finder, then what you'll do is you will find source code from here. All right, so I'm going to check Flaw Finder, pick the version. It's up here, right? Cool beans. All right, Flaw Finder's there. I am going to click on open source software here. And then I'm going to choose C, C++, right? Let's look at C++. Turbo, VNC. I'm going to go to see the project. I'm going to go to files. I'm going to go right here. And I need the tar file. So I'm just going to get the tar file. The tar file is downloading. Downloaded. Let me go to my desktop. Extracted. Okay. All right. So it's there. So CD, desktop. All right. So it's here. And so what I'm doing now is, all right. So now I have the Turbo VNC. So I'm going to do Flaw Finder, Turbo. All right, and you can see that it ran, right? So everything ran fairly quick. So it shows that I got the higher the hit level, the higher criticality. So you see right here, like 5, the highest, I got 6, then 4, right? Hit per level. But I'm like, this isn't working exactly. I need to put it somewhere. So I'm going to redirect this. Turbo result.txt. Gonna just write in here. We'll just let that run. All right. All right, cool beans. Okay. So you can see here, the header files, everything's here. examining all these files. There's a lot of files I'm examining. And now it's showing exactly the CWE, right? 340, CWE 120, right? It's showing exactly what it is. So now I can see exactly what the issues are. A lot of buffer. CWE 120 has come up quite a bit. So everything is shown. Everything is right here. So now I have this particular text file that contains everything that I've done. Now, what is CWE 120? So now I can say MITRE CWE 120. Go to the MITRE Corporation page. I'll share the link so you can search yours. And boom, it's right there, right? So it's showing everything about that CWE just like that. Fairly easy. Showing me the one, if it's a parent of one, if it's a child or another, is it related to other ones? Everything is being shown right here. So all you need is source code to do this. That's it, right? That's all you need. It's not entirely difficult. Okay, so if you look, like I said, if you look here, you can see everything here. You can look at various views for customized information. And that's pretty much it. So I'm going to do this. So there's actually an assignment that deals with this. And I'm pulling up the assignment. It's here. And this is what we have. All right, so the assignment is source code analysis using open source tools. And here it says, choose any source project from SourceForge that uses a programming language of your choice. Just hit Flaw Finder, C, C++. Briefly describe the selected project, the programming language it employs, static code analyzer, you use one of these tools. You explain why you chose it. You'll analyze the code. You'll talk about the CWE, and then you'll present it. So this is what you'll do. You'll be in groups no more than 4. And so what I'll do is you can go in the discussion board now and set up your groups, and then I'll create breakout rooms for you guys right now. So I've created breakout rooms just now. So now you guys can see the breakout rooms. I've opened them all. So you can choose breakout rooms, and you can take a look at the assignment. And then we just did Flaw Finder. You can use Flaw Finder. There's other tools as well. I'll go with the other tool in class. But what you can do now is you can at least break up in your group and then run the actual source code yourself. And then let's make sure that it works. Because sometimes you have issues in terms of maybe having Flaw Finder run against the source code and things of that particular nature. And so we'll do that. All right, I'm gonna stop sharing. I want someone else to share, and I want to see what you've done or what you're able to do. So I'm gonna stop my share, and I'm gonna let one of you guys share. And so share with me what you're able to do, and let's make sure that you're able to use this particular application.
Room 3. Hello.
Sorry, I couldn't hear for a sec. Could you repeat that?
Did you see the Discord?
Give me a sec. Oops, sorry, I didn't.
Oh, you're good. You're good. We'll see you there.
Okay.
Bye.
Hmm. Oh, great.
Was I going too fast or what?
Basically, yeah.
Okay. Apologies about that. I try to move at a decent speed, and sometimes I'm moving a lot faster than I should be.
Okay. Can you see it?
I can see it.
Okay. So I just kind of got lost at the part where you're like giving us an example on the turbo.
Yep. So go to Files. Mm-hmm.
Come on. Are you serious? Oh, there we
It's
go.
moving. It's moving. Don't rush. They say don't rush perfection. But I think they usually say that with plastic surgery, but that's another story. Okay. Go to the 3.091, the 3.1 beta 2. And now go for the the tar file, the tarball. So the last one, the tar.gz.
Okay. Oh. All right. Then what?
Now unzip the tarball.
Eesh, I think I forgot how to do on the command line. So, huh? Oh, that's why.
Yeah, you can do tar space dash xf.
Okay, so I unzipped it. What's next?
Okay. Now go to the folder that this particular directory is contained in.
Oh, okay. Oh, great.
Yeah, don't go into the don't go into Turbo VNC. You can just do flaw finder against the entire folder.
Oh, okay. So file finder, then that.
Now use that tab to do the autocomplete.
Go. And that's it.
Yeah, how do you feel?
Well, that was easy.
Yeah, so one of the things that you want to do is write this to a text file, and then you
Oh.
want to look up and see what was the vulnerability that came up the highest, right? So you can go to the manual for Flaw Finder, and then you can have it tell you the highest vulnerabilities. You can
Okay.
change those so it shows. So go, yeah, okay, we'll look after this, and then I can see your screen, so you can just click on your directory to the right. Just click on it.
Yeah.
Yep.
And what happened?
Yeah. Let's see. Do you have it here?
All right. You talking about the file creator or what?
Oh, that's the file. Now, what you want to do is use the man command, manual
Oh.
command, to figure out how you can output just the highest vulnerabilities.
Oh, okay. Like, you want me to do this now or like off class time?
Oh, I mean, this you can do it now. I mean, you don't have
Okay.
anything else to do you?
All right. I was just making sure because I was like, oh wait, maybe you were like waiting for me to leave or something.
No, you're okay. I mean, technically, I'm still on your time, right? So,
Mm-hmm.
Hi, so in the breakout rooms, are we just like trying one of the source analysis tools or
yes. And then what we're going to do Thursday, we're going to do two more different tools. We're going to use find bugs and another application.
okay, so the assignment says to record a video. Is that just something we'll do on our own time or
Yeah, you do it in
does
your own
this like
time.
replace that? Okay. Okay. Yeah.
All right. Do you have a group yet?
Yeah, I was just in there. We like kind of were doing it, so I wasn't sure how long or like what we're doing. But yeah, we got it figured out. Thanks.
Okay.
Did I do that correctly, Professor?
Let's see. Wait, go down. Go down, go down, go down.
Oh, okay.
Let's see. No, hit up real quick. Here, hit up. No, 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 no. Go down. Go all the way down. Hit up on your space bar in the terminal.
Oh, okay.
No, because it should be showing the other errors.
Okay. Thanks for letting me know.
All right. Okay, let's try this. You know how to look up a CWE, right? Let's take a CWE and let's look it up.
Uh, I just realized I was muted. Oops.
Oh, you're okay.
Ah, dang, I gotta get the link. Huh? Oh. Give me a sec. Oh.
Are you searching anything in the search bar? Or are you looking for CWE?
I was just copying the link.
Uh,
Was it this place? I forgot. So what do I do exactly?
okay, so here is where you find out more information about the CWE, right? So it says CWE 120. Now you can figure out relationship with the CWE. What does it actually mean? How is it exploitable and stuff like that?
Okay. Is it really just that?
Yeah, it gives you all the information, like at what phase do you fix it, um, how to detect it, weaknesses, what is it related to?
Mm-hmm. Yeah, it's a lot of information that I can't even process.
It's okay, you don't have to like process everything at once, but it's there so you can see exactly what the issues are, how to go through and correct it. And that's sort of the important matter.
Okay. Mm. Okay, thank you, Professor.
No problem.
I guess I'll see you in 2 days.
Yes, you will. You'll see me in 2 days, bud.
All right. Bye, Professor.
All right. Night. All right, and we close the rooms. All right, everybody's coming back now. What we're going to do is we are going to, 17 minutes. 17 seconds. Everybody back in the room. All right, awesome. Everybody's back here now. So what are we going to do? We are going to use another 2 tools on Thursday. I'm going to finish the presentation, going through the lecture, and then we will just continue. So keep your group, start working on your stuff. We will use something for JavaScript coming up on Thursday. I'll show you another tool, and then I'll be sure to send out an example publication of how the tools actually have been used to look at an official application. So I'll send that out. I'll be sure to send out those links. All right, any questions before we head out? All right, if no questions, I will have this posted by the end of the business today, and then I'll see you guys Thursday, all right?
See you Thursday then.
All right, see you guys. Cheers.
Take care, Professor.
All right, bye, bud.